Ukraine.
And Kangaroo at Greenland.
This is Karen Trioxide
And Lily Barium.
Today reporting to you with the daily environment news.
Today on Hoax News, we will have a special segment where we will be reporting about the tragic and surprising incident regarding the Greenland sea ice sheet hitting record lows in the year 2016 and 2017.
I'm Karen Trioxide.
And Lily Barium.
And the 10-minute rundown starts now. Due to human-caused global warming like burning fossil fuels and natural forces, the natural process that provides a greenhouse effect has been affected, which in turn has increased global temperature fluctuations. More specifically, a concern has arisen in regards to the Greenland sea ice sheets increasing melting patterns in the eastern and southeastern coast of Greenland, near the Arctic and Atlantic Ocean region. This has captured the attention of many because this issue can be a disaster of global proportion, and more specifically, the people of Greenland will be affected firsthand.
Greenland's sea ice sheet is vital towards helping moderate global climate because its ice and snow has one of the highest albedos compared to other Earth surfaces. Furthermore, sea ice is a form of translucent Earth material where specular reflection occurs. As a result, the ice transmits some incident light, and according to the laws of reflection, the reflected rays angle is equal to the incident rays angle, meaning that the 50 to 70% of the solar radiation exposed to the ice is reflected back out to space.
However, global temperature fluctuations are jeopardizing this very important process. More specifically, rising global temperatures have a severe impact towards Greenland's anomaly. As the area covered by ice and snow gets smaller, the amount of energy that is reflected by the ice's surface decreases. This is also known as albedo reduction. This action is concerning to many environmentalists because the sunlight that would have been reflected by the ice's surface instead gets absorbed by open water, warming it up.
As a result, ocean temperatures increase, and this heat through evaporation is then released back into the atmosphere, raising atmospheric temperatures as well. In turn, this melts more ice and decreases albedo. As a result, this is occurring chain reaction is classified as a positive feedback loop. It is largely for this reason that the Arctic and Greenland sea ice regions are reducing in mass and warming twice as fast as it did in the past. For more details, we reached out to a special guest from NASA. Please welcome the head of SRE, physicist Neela Strongarm.
It is a pleasure to be here, and this is an out-of-this-world experience. Now, my department and I are really concerned about Greenland's rapidly melting sea ice. Therefore, to monitor the melting of the Arctic and Greenland sea ice, we have been using the Advanced Microwave Scanning Radiometer, also known as AMSRE. This instrument is used alongside the Aqua satellite and the Special Sensor Microwave Imager. This system of satellites passes over the polar regions several times a day to gather data, and the process goes as follows. The concave-shaped satellite dish, the AMSRE, directs Earth-emitted microwaves radiation into an array of 6 feed horns, also known as the sensor microwave imagers. Then this microwave radiation is fed into the detectors, and after this process, physicists like myself and researchers can also form the data into images and publications, as well as animations of the melting sea ice for analysis and publication.
That sounds remarkable, but quick question, Ms. Strongarm. Why does the AMSRE instrument use microwaves to view Earth and see from space instead of other types of electromagnetic waves like gamma rays or X-rays?
That is a good question. Now, the AMSRE uses microwave energy for 2 reasons. One, radio waves have the longest wavelengths in the electromagnetic spectrum, and as a result, they are very good for transmitting information over long distances, and in this case, from outer space to Earth. Secondly, radio waves have the advantage that they can penetrate through sunlight, snow, clouds, and rain without them observing and affecting these observations. So due to these reasons, this is what makes radio waves exceptionally good for viewing Earth's sea ice specifically, through the use of the Advanced Microwave Scanning Radiometer, also known as AMSRE.
Thank you for your time, Ms. Strongarm, and good luck with your research.
Thank you. Next up, we have a local guest chemist from the Greenland Institute of Natural Resources, Ms. Maggie Nesium, who is going to be explaining the effects of the sea ice fluctuations on the Arctic Ocean's carbon dioxide and pH balance.
Thank you for having me on this fine evening. Now, it was not until recently that scientists and chemists like myself have realized that sea ice has a significant influence on the Arctic Ocean's carbon dioxide and pH balance. And unfortunately, through our data, we are already seeing changes on large scales in Greenland and the northern regions of the world. First of all, it is important to note that sea ice forms a natural barrier on the Arctic Ocean, which limits gas exchange between the water and the atmosphere. Therefore, the sea ice shares a pivotal absorption role with the Arctic Ocean, which is acting as a carbon sink. Therefore, when the sea ice melts due to rising temperatures, chemists like myself become very concerned because vast amounts of carbon dioxide dissolve into the ocean. And quite frankly, we have already seen these significant changes in the Norwegian and Greenland sea ice, in which their surface water contains higher carbon dioxide concentrations than the atmosphere. This is when it creates an imbalance in ocean acidity.
Could you further explain the chemical process to our viewers at home?
Yes, of course, the chemical process is quite simple actually. So when carbon dioxide reacts with seawater, it rapidly converts into a substance called carbonic acid, H2CO3. This is concerning because the chemical composition of carbonic acid makes it diffuse more hydrogen ions into the seawater. Therefore, the more hydrogen ions present, the lower the pH of the seawater is, which is making it more acidic. This can be very destructive toward the ocean's ecosystem because it needs to stay within a certain pH range of 8.3 to 8.4 for optimal marine health. So controlling CO2 levels is vital for survival. In fact, according to the Greenland Institute of Natural Resources, other marine chemists like me have already estimated that the pH of the world oceans have already dropped by 0.1 pH units since the beginning of the Industrial Revolution, resulting to a 25% increase in ocean acidity over the past 2 centuries. Now, what is really worrying about this issue is that roughly 22 million tons of human-created CO2 emissions are already absorbed into the ocean. And the more acidic the ocean becomes, the less it is able to absorb CO2. Wow, I'm sure that our viewers learned a lot. How about you, Karen?
Yeah, of course. The pH 3, I already have that one. I'm waiting for the new pH 4 to come out, though.
Anyways, for our last guest appearance, we have very interestingly named marine biologist, Mr. Bronchi Tubey. Hello, I am biologist Mr. Bronchi Tubey, and today I have with me my special student volunteer,
Miss Stem Cell.
As your guest chemist previously mentioned, acidity levels in the Atlantic and Arctic Ocean have been on the rise, and my job as a marine biologist is to further investigate the effect of ocean acidification on marine life, but more specifically coral, which is one of the building blocks of sustaining marine life all across the Earth's ocean. Now, this issue is concerning because coral reefs form the most biodiverse habitats in the entire ocean, and their presence is essential to thousands of other marine species, many of which we rely on for food. Now, moving on to the biology of the coral itself. Coral reefs are intervertebrate animals who belong to a large group called Cnidaria, and the most unique features of corals is their highly evolved form of symbiosis. This extraordinary process goes as follows. So each coral polyp, which is the name of one coral intervertebrate, develop a relationship with tiny prokaryotic plants, known as zoothanial. These microscopic single-cell algae live inside the tissues of each coral polyp, where they perform gas exchange and exchange nutrients in order to survive. Moreover, coral is very sensitive towards change in the ocean ecosystem, therefore making it highly susceptible to environmental stress. Recently, it was recognized that ocean acidification and rising carbon dioxide levels due to large amounts of Greenland's melting sea ice have contributed majorly to the deterioration of coral colonies.
Biologists like ourselves have discovered that water acidity inhibits the process that allows corals to form skeletons, partially because these high levels of carbon dioxide present in ocean water have affected corals' absorption of calcium carbonate due to high levels of environmental stress. Now, environmental stress occurs among these corals because the coral's body chemistry has adapted to millions of years of relatively constant and not fluctuating chemical conditions. However, with this inconsistency of pH levels, the tissues and organelles within this specific marine life, the corals, is not able to function and really perform the beneficial process of creating these limestone skeletons protect these tiny prokaryotic plants known as zoothelial. As a result, the zoothelial leave their tissue and the corals become unhealthy and they lose their vibrant colors. This is very significant really to the health of the ocean's ecosystem because these corals take on very important biological roles and are ecologically vital towards maintaining the world's oceans and really biodiversity. To conclude, us biologists foresee Greenland's melting sea ice and its consequences as a possible contributor to the future mass marine extinction of corals, more specifically in the future. And thank you so much for giving us the opportunity of being a part of this 10-minute rundown.
That concludes our special segment. I'm Karen Trioxide
and Lily Berriam, and see you next time on Hoax News. If we don't change our choices, we won't have this next year!